Welcome students. Today our learning objective is about circumference and arc length, and we're going to review some vocabulary first before we get into our new concept, which is arc length. I hope that you saw my note on the website to make sure that you do not print these front and back, because we're going to use the back of the page on the second page. Okay, so if you did, don't worry about it. You can just write what we add to it on a separate sheet of paper, but make sure you bring that separate sheet of paper with you to class and you attach it to your notes. Okay, first of all, let's just remember what is the definition of circumference. And we've always defined that as, since way back, as the distance around a circle. Okay. And remember that circumference, we don't measure that in degrees, that's measured in units. Not units squared, because that's area, just plain units like inches, feet, yards. All right, arc of a circle, the arcs, those are measured in degrees. So I'm going to put degrees here. And remember, from notes 10.2, that that's a part of a circle that's measured in degrees. And you can have two kinds of arcs, well actually three, but one has a different name. It's not called an arc, it's called a semicircle. But you can have a major arc or a minor arc. So the arcs can be major. And remember from 10.2 we learned that that meant that the measure was between 180 degrees and 360. So arcs can be major or minor. And remember that minor meant less than 180 degrees. Okay. Our new vocab word for today is arc length. And arc length is different from arc of a circle, because arc of a circle is measured in degrees, but arc length is measured in units. It is a portion of the circumference. Of a circle. Okay, so let's just remember the circumference of a circle, how it's found. The circumference of a circle is pi times the diameter, or it's going to be 2 pi r, depending on if you have the d stands for diameter, r stands for radius. So depending on whether you have the diameter or the radius, these are the two that you will use. So where d is the diameter and r is the radius of the circle. All right, arc length corollary. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. Okay, so what that means in English is that the length of arc AB, so right here in green, so this length, the distance from point A to point B, I know it's on a curve, but we can still get out our measuring tape that bends and measure around. Okay, so arc length of AB over the circumference, which I'm going to write down as 2 pi r, is equal to the measure of the arc, so that's measure of AB, minor arc AB, over the total circle, which is 360. Okay, now you can manipulate that. So if you look at this, you can manipulate this, and just, if you're trying to find the arc length, you can move the circumference over to the other side. by multiplying both sides by circumference. So here, let's just write down, this is the measure of AB over 360, and then we move this 2 pi r over here. 2 pi r. Okay. Alright, so now we're going to do some examples. Okay, so here we have some examples. And I want you to notice that in these examples, it just says, find the circumference of a circle with radius 9 centimeters. It does not tell you anything about rounding. So that means that they want an exact answer. If they don't mention rounding, exact answer. Exact answers are in terms of pi. So add that note up here. It did not say rounding, or the question or problem. Problem does not mention rounding. That means they want an exact answer. And that means that you'll have pi in your answer. We call that in terms of pi. So you'll see that on some of the standardized tests, like the STAR or the TAX test, they will say, leave your answer in terms of pi. And what that just means is that it's the exact answer, and it just has the pi symbol in your answer. Okay, so I'm going to start off with the formula. They want the circumference, and they gave me a radius. So this time I'm going to use the circumference is equal to 2 pi r. So I'm going to plug in what I know. Circumference equals 2 pi times 9. I'm going to multiply these two numbers together, and whenever I write my final answer, I always have to put the number in front of the symbols. So 2 times 9 is 18, so it has to be written 18 pi, and make sure you put your label centimeters. Don't put pi 18. It has to be the number first and then the pi symbol. Alright, the next one, they're asking for circumference, and they gave me the diameter. So this time I'm going to use circumference is equal to pi d. Okay, so plug in what I know. Circumference is equal to pi times 5. And when I write my final answer, remember how I have to write it. That's going to be 5 pi and then inches. And that's pi symbols, funny looking. 5 pi inches. Next, this time they want me to find the radius. And they gave me the circumference is 26 meters. Okay, so I'm going to start off with circumference is equal to 2 pi r, because I want the one with the radius. Alright, then what I can do here is, it's called manipulate the equation. I'm looking for r, so to get rid of the 2 pi and get r by itself, I can divide both sides by 2 pi. Notice how I haven't plugged anything in yet. I'm just trying to manipulate the equation. The 2 and the pi cancel out over here, and that leaves me with the radius equaling the circumference divided by 2 pi. That's called manipulating the equation, and you're going to do a lot more of that next year. So we're going to practice it in this lesson. Okay, so here I'm going to fill in what I know. My radius is going to equal, that's 26 divided by 2 pi. Did they mention rounding? If they don't, then you have to leave it in a reduced form. So I take the 26 and the 2 and I divide it. That gives me 13. So that's 13 over pi meters. And I leave it just like that. Okay. The next one. This time they want the diameter, so I'm going to use circumference is equal to pi times diameter. And again, I'm going to manipulate the equation so I can get d by itself. So I'm going to divide both sides by pi. So I know that the diameter is going to equal the circumference divided by pi. Plug in what I know. So that means that the diameter is going to equal, the circumference they gave me was 17 feet, divided by pi. And it doesn't reduce, so, and they didn't ask me to round to anything, so I don't plug it into my calculator and change it into a decimal. I leave it in terms of pi. Alright, next. Use circumference to find distance. Okay, well, distance traveled, when you are traveling, I'm going to write this on the back. When you're traveling, this is your distance traveled. And you're in a car, and you've got your wheel here. When you go a certain distance, your wheel, the circumference of the wheel, from here to here, from the starting point all the way around to the end point, if it ends here, then that's going to be called 1 revolution. And how many times your wheel turns will determine how many revolutions it is to get from point A to point B. So what we know is that the distance traveled is going to equal the number of revolutions times the circumference. Now that's really long to write, so I'm going to shorten this with distance traveled equals revolutions times circumference. Okay, so that's what that stands for. So you're going to see me write that over here. The distance traveled equals revolutions times circumference. The dimensions of a car tire are shown in the diagram at the right. Now what they show here is that the rim from here to here is 15 inches. The tire part of it from here to here is 5.5 inches, and the tire part down here is 5.5 inches. So I can't really find a radius, but I can find a diameter all the way across the circle through the center. All I have to do is add 5.5 plus 15 plus 5.5. And when you add all these together, you know that your diameter is equal to 26 inches. Okay? So, when I come back over here, I'm going to change my circumference to the one with the diameter, so the distance traveled will equal the number of revolutions times pi times diameter. Now I'm going to plug in what I know. It says, to the nearest foot, how far does the tire travel when it makes 15 revolutions? So the R becomes 15, and the diameter becomes 26. And remember, you always, even though it says pi d, you always write the number before the pi. So I'm going to put 26 and then pi. Now, on this one, did they ask me to round? Okay, it's right here, to the nearest foot. That means round, this right here, means round to the ones place. To the nearest foot, nearest dollar, nearest cent, that's to the ones place. Okay, so here, I plug this into my calculator just like that, and I get distance traveled will equal 390 pi inches, or, well, I'm going to leave it like that. Okay, so 390 pi. I'm not going to plug it into my calculator yet. And the reason why is because if you notice, this right here, 26, that was in inches. So right now, that 390 pi, that's in inches. So I have to convert this into feet. So what I do is I put what I'm given, 390 pi, and I put inches over 1. Take what you're given and always place it over 1. The label that you want to get rid of, you want to put it down here so that when you multiply it, they're going to cross cancel. The label you want to change it into goes up top. So inches and feet. Now what do you know about inches and feet? Well, I know that 1 foot is going to equal 12 inches. So I put the 1 up here with the feet and the 12 down here with the inches. Then I cross cancel and multiply straight across. That's going to give me 390 pi feet over 12. Now plug that into your calculator and you'll get something like 102 point something, 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 something. So when you round this, we always use the approximate symbol. It's the squiggly line equal sign. And that's going to be approximately 102 feet. So when this tire right here turns 15 times, it's going to travel about 102 feet. Okay. And by the way, if you're checking in your calculator, that should have been 102.1017612. So that's why we rounded to 102. Okay, I want you to do this one, but be careful on this one because they gave you the distance traveled this time. So you will plug that 500 in for dt. And then you still see how you have inches and feet. You're still going to have to do some conversions in order to get the right answer. So make sure you try this one and bring it to class. And if you don't get it, you need to make sure you put a question mark here so you can ask that so we can go over it in class. Okay, next. Now we're going to move on to arc length. Find the arc length. Okay, we've got the circle here, it's circle P. And we want to find the measure of AB. Now remember, when I have this little M here, that means degrees. So the measure of AB is going to be the same as the central angle, which is 60 degrees. And when I want to find arc length, remember that that's just a portion of a circle. So here's where we're going to pause, and I want you to flip this over to the other side. Or get a blank sheet of paper, either one. Okay, so if you want to just jot these down on a blank sheet of paper, you can do that. I'm going to put mine on graph paper. All right. So, when you are looking, I'm going to start here with looking for the length of an arc. Okay, when I'm looking for length of the arc, I'm going to start with arc length equals the measure of the arc. I'm just going to use the word arc, the measure of the arc over 360, because that'll give me my portion, and then I multiply that times the circumference, and I'm just going to put circumference over 1. Okay, so I just multiply these together straight across, and that will give me the arc length. Now, what if I'm looking for the circumference? I want to manipulate this equation up here so that I end up with circumference on one side and everything else on the other side. Okay, so arc length, so if I just take this, arc length over 1 equals the measure of the arc over 360 times circumference over 1. Okay, so if I want to get C by itself, I have to get rid of this. To move this over to the other side, I'm going to multiply both sides. This side here and this side here by the same thing. and multiply by the reciprocal of this. That's going to be 360 over the measure of the arc. And so they can cross out over here, and 360 times the measure of the arc. Okay, so let's clean this up. That means that this over here, the only thing that's left over here is the circumference. So I'm going to write that down over here, circumference equals, so circumference equals, and then I'm going to write this down. That's the arc length multiply straight across times 360 over the measure of the arc. Okay. Now, what if I'm looking for the measure of the arc? Okay, and that's arc, if I'm looking for this guy right here. Okay, well, I want just to get this guy right here by itself. So I'm going to start with my original equation. Arc length equals, that's measure of the arc times circumference over 360. Okay, well, I want to get rid of the 360 and I want to get rid of the circumference. So what I can do here is I can multiply both sides by the same number, and this one I want to put the 360 up top because I want to get rid of it, and I want to put the circumference on bottom because I want to get rid of it so it will cross out. So C crosses out with C, 360 with 360. So I'm going to multiply by 360 over C on this side. So what's left over here is the measure of arc AC. So I'm going to write that down. The measure of the arc is going to equal arc length times 360 over the circumference. Okay, so I've manipulated this same equation twice. We're going to do it again. Let's say that we are looking for the diameter. Okay, well, I know that the diameter is part of the circumference of a circle, so I'm going to start here with circumference of a circle. And I'm going to put circumference is equal to arc length times 360, and that's divided by the measure of the arc. Okay, so that's where I'm going to start. But I'm going to change this into pi times diameter. Okay, so this becomes pi times diameter is equal to the arc length times 360 divided by the measure of the arc. Okay, if I put this over 1, how do I get rid of the pi? Because I'm looking for the diameter, I just want d by itself. Well, I divide both sides by pi, or multiply by 1 over pi. Okay, so here, multiply by 1 over pi, that cancels out, multiply by 1 over pi. Okay, so diameter equals arc length times 360 over the measure of the arc times pi. Okay, I have one more. We're going to do this again, and this time we're going to look for the radius. So, looking for the radius. Okay, again, I'm going to start with the circumference. So, circumference is equal to arc length times 360 divided by the measure of the arc. And yes, I'm going to substitute in my equation for my circumference. It's going to be 2 pi r. That's going to be arc length times 360 over the measure of the arc. Okay, now this time I want to keep the r on the left-hand side, but I want to move the 2 pi over to the other side. So I'm going to multiply by 1 over 2 pi so that they will cancel out. Multiply by 1 over 2 pi on both sides. That leaves me with the radius is equal to arc length times 360 over the measure of the arc times 2 times pi. Okay, and then you can manipulate this even more and say, you know, and reduce the 360 and the 2 and just say, cancel that and make that 180 if you want. So we can write that down too. Arc length, okay, that cancels with that, so that would be times 180 over the measure of the arc times pi. And that just gives you a little bit less to plug into the calculator. Okay, folks, so these are all the equations actually that you're going to be using, but remember, you don't have to memorize them because you can just manipulate them. So I'm going to go back and highlight these in blue. So when I'm looking for the length of an arc, here's my equation. When I'm looking for the circumference, here's my equation. When I'm looking for the measure of the arc, here's my equation. When I'm looking for the diameter, here's my equation. When I'm looking for the radius, you can use either one of those equations here. Okay, there you go. All right, now back to our final page. Okay, our second page. Okay, so moving that up. So we focus here, and we are looking for the length of the arc. So we're going to use this one right here. So I'm going to take the arc length. I'm going to write down length of AB equals the measure of the arc. The measure of the arc was 60, so I'm going to plug in 60 over 360. And then I have to multiply that by the circumference. Okay, so that's going to be multiplied by the circumference. So now I have to find the circumference. So what I know is that the radius is 8 centimeters. So that's going to be 60 times 2 pi r. Okay, remember this one's going to be the 2 pi r. So that's going to be twice the radius. So twice the radius is going to be 16 pi over 360. Okay, now let's reduce that. Let's reduce the outside first. 60 and 360, so that's going to be 1/6. And so that's going to be 16 pi over 6. And then that still reduces by 2. And that's going to be 8 pi over 3. And I need a label. Now remember that the length of an arc is measured in units. So I figure out what units I have, and that's centimeters. Okay. They didn't say round, so I have to give the exact answer. Alright, that's how you do it. So you're going to do number 8 and 9 by yourself, and you're going to bring those in. Okay, next page. Okay, I'm going to set these up for you, and then you're going to bring in the rest. Okay, let's look at our equations. This one says find the circumference. So looking for the circumference. So this one I'm going to use circumference is equal to the arc length times 360 over the measure of the arc, whatever arc they're talking about. Okay, so over here we have a circle Z, our arc XY. We are told that this central angle right here is 40 degrees. We are told that the length right here of the arc is going to be 4.19 inches. So we have everything we need to plug it in and find our circumference. All right, the next one. Okay, highlight that in yellow or whatever color you want. Make sure you finish this one and bring it in. Okay, the next one says find the measure of RS, round the answer to the nearest degree. So this one you're rounding, folks. Okay, so here, find the measure of the arc. So here it is, looking for the measure of the arc. I'm going to use measure of the arc equals the arc length times 360 over the circumference. Okay, this time, take a look at what you're given. You're told that RS, and we're looking at this minor arc RS because it just has 2 letters, so we're not looking at this one because there's not another letter. So that's going to be 44 meters. And then here, you've got 15.28 meters. And it's pointing to this piece right here. That means the radius. So this time you have to use your circumference formula and figure out what the circumference is first. You already had the arc length here, so plug in what you know, and then find this. Make sure you round to the nearest degree. You're going to finish this one on your own and bring it in. Okay, the next one, find the length of arc PQ. Okay, so the length of arc PQ, that's going to be just the arc length. So arc length is equal to the measure of the arc times the circumference divided by 360. Okay. But the problem here is that you don't have the circumference. It's not given to you, so you have to find it. Well, and you have to find the measure of the arc length too, because it's not just given to you. So you have to look at your circle. What I know is that this central angle right here is 75 degrees, and I'm told that this diameter is 9 yards. So you've got 75 degrees and 9 yards, so you're going to have to go and figure out what these pieces are, plug it in, and bring it in. Notice how they didn't say round, so that means that this is an exact answer. Okay. So this one up here didn't say round, so this is going to be an exact answer. This one says round, so you're going to round to the nearest ones place. This one doesn't say round, so it's going to be exact answer. Okay, the next one. On the next one, it says find the circumference. So again, you're going to use the same one up here. Circumference equals arc length times 360 divided by the measure of the arc. Okay, so they're talking about this time you're using the major arc. So here, this 61.26 meters, that's the length of arc MXL. The length of MXL. And you know that this 270 degrees, that's the measure of arc MXL. It's 270 degrees. Okay, so this is in meters, and this one is in degrees. So plug it in and solve. And notice how on this one, they did not say round, so that's going to be an exact answer. So I'm expecting you to finish this one and bring it into class. All right, the next one, the last one for today is finding the radius. So you're going to use that last one that we did down here, and you're welcome to use either one. It doesn't matter. I'm just going to cover that up. Okay, so here I'm going to put down radius equals, and I'm going to use this final one over here, arc length, and that's just my personal preference. It doesn't matter to me what you do. Times 180 over the measure of the arc times pi. Okay, this one says round to the nearest foot. So you're going to be rounding on this one. So here you've got 10.5 feet, and that's this arc length here. You've got 150 degrees, which is the measure of the minor arc. So you can plug in what you know and make sure you round to the nearest foot. So you finish this up and you bring it into class. Okay, folks, that's it for our notes today. That is notes 11.4, finding the circumference of the arc length.